Hey, this is Josh, and today we're going to be solving radical expressions. So I actually wrote the word solve up here because that's what we got to do. Notice you'll have an equal sign on these types of problems because that's what they're looking for you to do, is come up with an answer, x equals something, or come up with some type of value as your answer. And I wrote and check. Now, most books don't say check. If you're just learning this, maybe it'll say check, but there's a certain type of check you got to do for problems like this. So let's get into these and we'll talk about that along the way. The first one here is square root of x minus 7 equals 0. Now, the way I like to present this is your goal, it gets all the way back to some of the stuff you did a long time ago, which is to get all your x's on one side and your numbers on the other. Okay, if you've watched my other videos, you know that that's what I'm really big on, is simplifying the work. Okay, look at your problem and then say, what do I have to do with this thing? I got to get all my x's on one side, my numbers on the other, and then I can start moving stuff around or working on the problem. So I have a square root of x minus 7. Now, this isn't in a parentheses, so it isn't a quantity. It's just something, it's like a plus 4, right? It's the same thing. So technically or legally, I'm allowed to get rid of the 7 from that side. Like I usually say, if you want to move ahead or if you want to try this on your own, that's okay. Try it and see what you get. Maybe now that you've seen that first hint, and then come back and see what you get. So what you do to one side, you got to do to the other. So my new problem here is square root of x equals 7. Now, you can't write an answer like that because that's like saying, oh, well, 4x equals 10. Well, that's not really telling me what x equals, right? You want to get it down to that single unit of x. And so for this type of problem, you just got to look at, well, what's the opposite? If it's telling you that it's a square root of x, then the opposite of square root is squaring something. So I usually put the parentheses there just because it reminds me. Some students like to skip that and just kind of put the 2 up there and remind them what needs to be done. Square root of x times the square root of x, right? Because that's what this is. This is technically square root of x times square root of x, right? And when you multiply these two together, the square root sign disappears. And so we end up with just x. 7 squared, 7 times 7 is 49. Done. That's as far as you can go. We've solved it, and then technically you should check and just make sure. Is the square root of 49, well, what is the square root of 49? 7. Is 7 minus 7 equal to 0? Yes. So therefore we've not only solved it, we've then gone back and checked. I really think that you should, if you have time to check your problems, like I always say, unless you're on some crazy math test where you ain't got time for that, then I would definitely try and check your work. It's really nice being able to turn in a test and say, I know I got them all right, because not only did I solve them, but then I actually took it that extra step and checked my answer. And it's going to be really important by the time we get into some of these other ones here. I'm going to leave these up on the board just because it's good habits. It's a good reminder. Usually when I'm teaching lessons like this in the classroom, I try to leave these signals up there. And why shouldn't you write this on a test, right? Why shouldn't you write this in your notes? Because if these are the little things that are going to help you get through this and get it right, I say do it. The next problem here, let's see, we have, this is big, 2x minus 3. You'll notice that the square root sign goes all the way over this guy. Then you have a plus 3 equals a 4. Let's apply the same rule as we did on that first guy. Let's isolate the variable part, okay? It's okay that this is all together, but we have this guy that's just kind of an outlier. So let's subtract 3 and get rid of that guy. And we have square root of 2x minus 3 equals 1. Okay. Same thing as the last problem. Just because there's a binomial or a quantity under here, I mean, this could be like 18 parts about down there. Just because there's all that down there doesn't mean that you can't square this thing. And yep, we gotta square the 1 as well. Just be careful when it comes to this, where we have the square root of all this squared, really just means that this part is just gonna kind of show up and come out, okay? So let's take that out. The square root sign cancels with the squared. And let's see, I guess we'll just get 2x minus 3 equals 1. And then let's start working through this problem as we normally would. So plus 3, so 2x equals 4. And that's pretty self-explanatory. Divide by 2, cancel, x equals 2. And then again, we should go back and check our answer, okay? Let's see here. Let's plug this guy in right here. 2 times 2 is 4. 4 minus 3 is 1. The square root of 1 is just 1. And so is 1 plus 3 equal to 4? Yes, it is. And so we've correctly solved it for x. Then we've plugged in and we've done our check. Now, a while back, and I've talked about this a couple times through some of my videos, sometimes you get answers that aren't, it's an answer to the problem, but it isn't technically an answer that works. And you see this a lot with quadratics, where you have 2 answers, and the question is, well, how high did he kick the football? And your answers are like -16 and 25. Well, can you really kick a football -16 feet in the air? I guess you could kick it down into the ground, right? And like do something like that, or you could like dive underwater or something. I don't know. But the point is, it's an answer to the problem, right? You're working through all this math and you get an answer, but then one of them or 2 of them might not work, right? They're solutions to the equation, but they're not really solutions when it comes to the final question you're being given, okay? And that's this type of problem, which is why I wanted to do one of these. If you already remember that term, then that's awesome. If you're not sure, the term starts with an E. I'll just start to write it out, and hopefully you'll say it out loud. Extraneous. Extraneous answers. You're going to check for extraneous answers on these types of problems, and you'll see why. Let's see here. Well, are my x's on one side, numbers on the other? Well, I kind of can't really do much of that right now. I mean, I guess I could move it all to one side and you know, make it a 0, but I don't have to. Let me follow the rule I already gave you, which is x's on one side, numbers on the other, and then kind of work through it in just a second. Let me first square both of these, because there aren't any like extra just numbers. It's all x stuff. And see what we get. Well, this cancels with this, so I end up with x plus 2 equals x squared. And at this point, I need to move everything all to one side, okay? Because now I do want to get my numbers on one side. So if I subtract an x and a 2, I'm going to get 0 equals x squared. Let's see here, minus x minus 2. All right, so far so good. Now, oh man, now we're pulling in all kinds of types of math, and that's awesome, because if you're seeing what needs to be done next, that is rocking, because it shows that you're really understanding Algebra 1, you're understanding how these concepts work together and what can and can't be done. So we have 0 equals this. We're getting into that thing called the 0 product property, right? I hope you remember the 0 product property, because what it says is that when you multiply all this stuff out, you know, as long as something is equal to 0, then something times something's going to equal 0 in the end. Hope that made sense, okay? It did to me, but I don't know. Hopefully if you're getting this far into the math, hopefully that made sense. What can I do with this guy? Because I need to solve this for x. Can I just start plugging in numbers and seeing like what numbers are going to make a 0? Yes, but what if this was like x squared minus 2/3 x plus 14.5? Dude, like you'll be here forever, okay? It's better just to go with what you know. And hopefully this problem is going to be written as a trinomial that's very workable. And when I say that, I mean we can factor that thing. Oh, that's right. I can factor this thing into two binomials. And hopefully you've watched my video on factoring binomials or factoring trinomials and creating binomials. And if that's the case, you should be able to factor this thing pretty quick. Okay, I know I have a -2 in the back and a -1 in the middle. So I have, what would that be? X minus 2, x plus 1. Okay, and what I'm saying is that 0 equals this times this. But is this solving for x? No, all I've done is just written out two binomials. I got to take it to that next level and say, okay, well, according to the zero product property, what number can I place here to make this whole thing here into a 0? What minus 2 will make a 0? Well, 2. And on the other one here, what plugged in right here will make this guy into a 0? A -1. So my final answer would be x equals 2 comma -1. Don't put parentheses around these because then it looks like an ordered pair and I'm a stickler on that kind of stuff. So just write it out like this. Okay, I've now solved for x, and now what do I need to do? Yes, you got to check your answers, okay? And you're probably saying, oh my gosh, dude, now I got to take two answers and plug them back in, and that's a lot of work. Well, that's the lesson, okay? And if you're getting this far into math, go that extra step. Don't just stick here and stop here and say, I'm done, because what if one of these answers doesn't work, right? You might need to pick one and come up with the extraneous solutions. So let's see. Let's see here. We got 2. Let's plug in a 2 here and a 2 here. So 2 plus 2 is 4. Square root of 4 is 2. And over here we have a 2, right? Because we plugged it in. So does 2 equal 2? Yes. So that one works. So this one is definitely an answer. Let's try the -1. -1, sorry, I'm kind of writing all over everything now, but you can see this clear enough, I hope. -1 plus 2 is going to be, what's that? -1 plus 2 is just 1. Square root of 1 is just 1. And over here we have just -1. So is -1 equal to 1? No, it's not. That's supposed to be a not equal to sign. Sorry, I tried to make it look pretty, but that's just what you get, okay? So 1 does not equal -1. Therefore, this is not a solution to this equation or to this original equation right there, okay? So that last part, the checking for extraneous solutions, is important. And I know you're probably saying, oh man, it's just like one more step. But think of it as just part of the problem. And sometimes you're not even going to have two answers. Sometimes you might even have a third. And so you just got to take your time. If you need to, maybe rewrite the problem, because see how jumbled this thing got? Like this thing got crazy in like a matter of minutes. So if you need to, maybe like give yourself some space before you start working on these, so that when you like have your final answer, then maybe you can like write out the problem again and, you know, nice and neat, and plug in the plug in your answers, or use the original equation. If you want to, you could use the original equation, just plug them in and then erase it and see which ones work and just make a nice little list. Again, even just by showing your work on that, you're really showing your teacher your understanding. And so hopefully if you were to get these answers, plug them in and make some minute mistake at the end, hopefully you'd get at least partial credit, okay? So any questions on this, send me a message, but check out my other videos. Take your time with this stuff. We're getting into technical math, but I think you can do it. Just follow these rules. Thanks for watching.